So, bicycle wheel. So this could be applied to any type of object that rotates. Bicycle wheel, 24 inches in diameter, rotates 100 rotations per minute. Find the angular speed. So omega is equal to theta divided by t. That's what we'll focus on first. In radians, what is one rotation? 2 pi. How many rotations is this bicycle wheel making? 100 rotations. So theta is 2 pi, that's one rotation, times 100. Divided by how much time passes by for those rotations to occur? 60 seconds or 1 minute, because it says rotations per minute. So 60 seconds. So this is a radian measurement on top. This is a seconds measurement on bottom. So in other words, I have 200 pi divided by 60. Cross off the zeros. 20 over 6 is 10 over 3. So 10 pi over 3 radians per second. That is the angular speed. Some people might wonder, why would you ever want to know angular speed? Why not just rely on the rotations per minute? Fine. But if we want to calculate the velocity, then having that value is going to make it really easy to calculate the velocity. Yes. I just stated that. It should say it in the problem. Yes. What's that? So this is angular speed. That's slow. That's fast. That's it. That's all it's talking about. So really the idea is, how fast do I complete one rotation is the idea. All right. So linear speed is velocity is equal to r times omega. What is my radius? 12 times 10 pi over 3. Get 125.66. And that would be inches per second. Okay. That's valuable information. We were able to come up with it pretty quickly by figuring out our angular speed. Let's try another one. Paddle wheel. I was fortunate enough to go to prom my sophomore year of high school. I had a good friend that asked me. She was a junior, and we went on a paddle boat down Mississippi. So we had our what do we have? We had our supper out there, and we had our dance out there on the paddle boat. Very cool. And we had an after prom party after that. It's kind of expensive, but I heard New Richmond does the same thing. Okay, yeah, very cool. All right, we'll figure it out. What? Oh, okay, you're thinking that. Okay, all right, got it. Yeah, that's dumb. Okay, paddle wheel is a radius, so I'll draw a paddle wheel. There's my paddle wheel. It has a radius of 0.3 meters. It rotates at 80 rotations per minute. I want to figure out the speed, or the velocity in meters per second. So in order to do that, what I'll do first is I will calculate omega, the angular speed, because velocity is equal to r omega. What is r? 0.3. So what I need to know is omega. So I'm going to calculate omega. Omega is equal to theta divided by t. Theta is my angle. What is one rotation around? 2 pi. How many rotations do I have? Divided by how many seconds go by? 60. Well, if it's rotations per minute, then yes. But if it was rotations per second, then it would just be 1. So you have to look at what the rotation is. It says that we're going to find it in meters per second, so we want it in seconds. If they said meters per minute, then we would have left 1 minute. It depends on what they're asking for. 2 pi times 80 divided by 60. And I got 8.38. And that's radians per second. What do I do with that value? Yep, so velocity is equal to 0.3 times 8.38. And I get 2.51. And that's meters per second. Okay, so that finishes up our notes from yesterday. Today we want to cover the next page, and you have a worksheet then for an assignment. Today's lesson is very fundamental to your knowledge regarding trigonometry. I'll say that what we just did here is not all that fundamental, okay? The fact is that we could actually do without this. If we decide to skip it, it's not that big of a deal. But this is crucial. Today you learned about 6 new terms. They are sine of theta. And here's how we define sine of theta. Everybody remember SOHCAHTOA? So what does the SO stand for? Sine. So watch. Suppose I have a point on my, a terminal point on my circle. Here's how it got its name. Okay? So that's my radius, right? Okay? If you strung a chord, so a chord, if you remember from geometry, stretches from one side of the circle to another side. A diameter is an example of a chord. Are all diameters chords? Yes. Are all chords diameters? No. So I string the chord as such. If you look at the angle that is formed, okay, we say that sine is the opposite side divided by the hypotenuse, correct? Well, here's what you should know. First of all, as we were calculating this, x, y, this opposite side is simply the y value, isn't it? And in the unit circle, what is always the hypotenuse? 1. So therefore, sine is the opposite side divided by the hypotenuse, which is just y. Now here's what they translated as in the Greek. They said it creates half of the chord. So the word sine actually meant half chord. It got translated from Greek and then to Arabic, and then from Arabic got translated to Latin. It went from Arabic to Latin. Somehow people made a mistake. And instead of translating to be half chord, they translate it as sine or sinus, which literally means your nasal passage. That's what happens. So every time I see sine now, I think nasal passage. All right. So sine, which is spelled out like that, but we shorten it like that, is y divided by r, which in the unit circle, because r is 1, is just the y value. Cosine is spelled like this. And cosine is not the y value, but rather the x value divided by r. Because the r value is 1, cosine ends up being just x. Tangent is spelled like that. And tangent, as you think of as opposite over adjacent, ends up being y divided by x. Can you tell me what does y over x remind you of? Slope, rise over run. The tangent of an angle is the same as the slope of the line. Yep, so that's a relationship. Okay, thank you for understanding that. This is cosecant of theta, secant of theta. And cotangent of theta. And the nice thing is, once you know sine, you know cosecant. It happens to be the reciprocal, or r over y. Secant is the reciprocal of cosine, so r over x. And cotangent is the reciprocal of tangent, so it is x over y. And those are the relationships that we express. Today you're going to do 3 problems in class. You're going to become very familiar with these. You're going to do a great job with them. We're going to draw a picture and use special triangles to calculate the exact value of the following trigonometric functions. And we are not just going to do sine of pi over 3. We are also going to do cosine of pi over 3 and tangent of pi over 3 and cosecant of pi over 3, secant pi over 3, and cotangent pi over 3. I'll tell you what, I'll give you a break. One of these 6 you could kind of shorten up, and that would be tangent. A lot of people do say tan. I think that that's a little bit more reasonable. All right. I'm going to use a little space here because I can't write as small as you can. In order to find out these exact values, I have to come up with the terminal point. Once I know the terminal point, I can figure out the rest. What is pi over 3 in degrees? What is it? 60. Somewhere you probably should. So we have xy coordinate. We're wondering what is that coordinate. So I make a triangle. 60 degrees is my angle. What special triangle does it make? You understand now why we've been creating these special triangles? Now we want to find exact values. That's 90 degrees. What is the radius? 1. What's the x value? And the y value? Good. So therefore, my terminal point for pi over 3 would be what? Good. 1/2 the square root of 3 over 2. Sine of pi over 3. Is it the x value, the y value? What is it? It's the y value. So that would be the root of 3 divided by 2. Cosine? X value. 1/2. Tangent, what do I do? Square root of 3 over 2 over 1/2. How do I do that? Multiplied by the reciprocal. You can see, as Noah said, that the 2's will cancel. You'll end up with just the square root of 3. Once I know those values, it's easier to find the other 3. How do I find the other 3? Take the reciprocal. Reciprocal of 1/2. 2. That was easy enough. Reciprocal of the root of 3 over 2. Very good. So it's 2 over the root of 3, but we can't have the root of 3 in the denominator. So we multiply the top and bottom by the root of 3. We get 2 roots of 3 over 3. The cotangent of pi over 3, I have 1 over the square root of 3, which is the root of 3 over 3. And those are my 6 trigonometric values. And they are exact. You have at least one, probably 2 to 3 problems like this on your test. Each one will be worth 6 points. I often have people who write IDK underneath these problems. Not acceptable. Every single person here is capable of learning those. Second of all, people will often then, if you don't know what you're doing, you'll type in pi over 3 into your calculator, you'll press sign, and you'll write 0.866. And I give you exactly 0 points for doing so, because I can teach Micah, my 7-year-old, how to do that. It says find the exact value. The exact value is the square root of 3 over 2. I can't teach Micah how to do that. You guys know how to do that. Exact value requires these values. Do you understand the difference? Don't give me 0.866. I'll get angry and I'll start making a lot of red marks. Okay, here we go. Tangent of 7 pi over 4. Who knows? What is the angle for 7 pi over 4? Or what angle do you think of when you see 7 pi over 4? 315. Did anybody think of 45 first? Well, that's what you should think of. And then that leads you to the 315. And so it makes a 45, 45, 90 triangle, right? And we're looking for that coordinate, x, y. So if I have a 45, 45, 90 triangle, what is the hypotenuse? 1. What are going to be the other sides? Hopefully you understand now why we spent the time converting 7 pi over 4. We want to do that quickly. You can see now why we want to do it quickly, right? You also understand why we want to come up with those values and not question how we got them. We now know that they are that. So my coordinate will be square root of 2 over 2 and a root of 2 over 2. So I have sine 7 pi over 4, cosine 7 pi over 4, tangent 7 pi over 4, cosecant 7 pi over 4, secant 7 pi over 4, and cotangent 7 pi over 4. What's the sine value? Negative root of 2 over 2. Good. Cosine? Tangent, if I take something and divide it by itself, I get. But these aren't exactly the same, so I get negative 1. What is the reciprocal of negative 1? Negative 1. If you have negative 1 over 1, you flip it upside down, you get 1 over negative 1, which is still negative 1, right? It's all right. People made that mistake the previous hour, too. So how about the reciprocal of the square root of 2 over 2? So you get, yeah, so 2 roots of 2 over 2, which ends up being square root of 2, right? So think about it, folks. Where did that come from? It came from this, right? And then when you flip that, you get root of 2, right? So it's root of 2. Nope, you don't switch the sign. Sign stays the same. Yep, and now I'll do the top one. That will be, as you said, negative root of 2. Very good. Last one. Want to see an easy one? Okay, we're going to do negative pi. So we're going to have sine of negative pi, cosine of negative pi, tangent of negative pi, secant negative pi, secant negative pi, and cotangent of negative pi. A for the day. Who can think of the terminal point for the angle negative pi? 180 is the degree. Negative 10 is the terminal point. Because if you were to sketch the circle, think about it, negative pi brings you right here. And what is that coordinate on the unit circle? Negative 10. Everybody see that? So do we need to draw a triangle? No, this is easy. So what's sine going to be? Sweet. Cosine? Negative 1. Tangent. Y divided by X is 0. Good. What's the reciprocal of -1? What's the reciprocal of 0? Undefined, because if you have 0 over 1, that's 0. If you flip it, you get 1 over 0, which is undefined. So those are easy, aren't they? Kind of nice, huh? All right. That was quick, but I need to do so because I haven't run off copies for the test next hour yet. So I'll give you your worksheet.